Hello, everyone. This is Alan here with Berkeley Nucleonics. Today, we're going to go over SAM 950 in the SAM 950 training. We're extremely excited to provide this training to you and to your group. This is a great way to kind of uh, introduce the new product to you, as well as kind of a refresher course or a good overview of the new features, the new applications, and everything that's being installed and upgraded to the SAM 950. Before we begin, just a quick overview of the company, Berkeley Nucleonics. We were founded out of a spinoff out of Lawrence Berkeley National Laboratory. We first started by developing nuclear instrumentation modules that was used for the development of atomic bomb testing, things of that nature. So we were first involved in the pulse generator world. After that, we got involved in isotope identification, uh, more so portable isotope identifiers. That's where we introduced the SAM 935 in the 90s. It was one of the most compact, reliable, portable MCAs in the industry. After that, we introduced the SAM 940, which was used in a wide array of applications from law enforcement, first responders, to the military, Air Force, and things of that nature. Since uh, and Lately, we've introduced our new SAM 950. Our new SAM 950 integrates all the new features, all the new requirements that are now being required for all of the new state agencies and all the new departments. So let's jump right in and go over our new SAM 950. So again, kind of an overview of what this training will entail. We're going to kind of go over the techniques, how to use the SAM 950, how to properly start it up, how to do proper isotope identification, maintenance, things of that nature, and basic concepts of what an isotope identifier is, what it's used for, and what's intended applications, and the terminology, some of the key features, some of the terms that need to be used while using the device. And we also want to avoid some issues or some common errors that we've seen in the past with the isotope identifiers. There are some assumptions, some old tricks that just aren't needed or can't be used with this new system. Again, we want the device to be reliable. We want it to work properly. We want it to meet the needs of the end users. So we're going to go through that, and we're going to allow you to train other people. We're going to give you insight, good insight that we've been collecting over the last 5, 10, 15 years. So we're going to kind of show you all the great new uh, adds, new features, but also some older kind of protocols and things like that that would need to be used and implemented when you start up your 950. And again, any questions, feel free to shoot them our way. I know that it varies between application to application, but any questions, feel free to send them our way after the training. So the SAM 950 is our latest isotope identifier. It's the most rugged, the most sophisticated, the instrument that has some of the most sophisticated uh, features that we've ever seen here at Berkeley Nucleonics and throughout the industry. We do now have more reliability with regards to battery. We do have now a touch screen. We do have that more rugged design that's going to protect your detector. The detector is one of your most um, costly kind of parts when you do acquire a system of this nature. So again, we're trying to make it as secure as possible um, by creating this new configuration. So you got your SAM 950. It arrived at your facility. It came in a Pelican case. You're ready to open it up. These are some of the components that uh, you'll see. So number one, you'll see the SAM 950. That's the system. That's the isotope identifier. That's the portable gamma spectroscopy system. You are going to receive a DC power adapter for your SAM 950. That's going to allow you to charge it, keep it running, and again, it uses a lithium-ion battery. You're going to receive a vehicle charging adapter, so you could use this vehicle charging adapter to charge your 950 either in a boat or in a vehicle, things like that. So you could always have it running even if there is no battery or outlet available. You're also going to get a shoulder strap. That shoulder strap, you'll attach it to the front end and to the back end of the 950, and this will allow you to um, carry or maneuver the device through this fashion. So again, those are the parts you're going to get. A lot of the software uh, is readily available online. You go to www.bncsam.com. You can upload the latest software updates there. We're going to kind of go over the software updates through the device, but you can also do it through the device. And we also include a manual and all the requirements with the device. So some of the key specifications of your new SAM 950. In the past, one of the issues that we had with our older devices was the storage capacity. Uh, we had maybe 1 to 2 megabytes that we could kind of use to store events. With this device, we have gigabytes. So it's definitely possible for you to include up to 10,000, 15 to 20,000 events in your SAM 950. You could attach pictures, you could attach videos, things of that nature. So we've definitely improved on the storage capacity. Your SAM 950 will come standard with uh, a scintillation crystal that will perform isotope identification, and it will come standard with a GM tube for your higher dose rate range. So your upper limit radiation is going to go from 100 nanorem per hour up to 10 rem per hour. So that's very high radiation levels. So chances are, if you do come across a scenario or a situation where you are um, in a level of very high resolution, high radiation, you still will be able to detect that high range up to the 10 rem. But chances are, if you're in those numbers, you want to get out of there. But if you want to detect it, you'll be able to do that as well. The SAM 950 does allow for neutron detection. We do use either helium or we do use solid state neutron detector. Through solid state neutron detector, we'll use a domino detector. All these, either or, depending on what the application is or what you'd like to use. But this system does allow for up to 3 detectors. Again, a scintillation detector, whether it be sodium iodide, lanthanum bromide, or cerium bromide. We do allow for a GM detector, again, for the upper limit, and also a neutron detector. The operational temperature is down to negative 20 Celsius and up to plus 50 Celsius. In all of our systems, whether it be the SAM 950 or whether it be the RD120, they are all ANSI compliant. So let's go into the operational instructions, how to use the device, how to turn it on, how to properly maintain it. So again, the SAM 950 is a very sophisticated isotope identification system, but uh, it's very easy to operate, easy to use, and easy to maintain. By simply following these instructions, you can have your SAM 950 working for at least 5 to 10 years. So the SAM 950 battery power charge. So this is going to be in the back end of the device. So you're going to see the power switch and the battery charging connector. So they're in the rear. So that the power switch is the metal power right there. You click on the power, it's going to turn red when it's on. If you want to turn it off, you just press on that. That's going to let you know that the SAM 950 is fully powered by looking at that red LED light, which is going to turn red. There is a charging connector, uh, the LEMO charging connector there to connect it to a power outlet. And then there's also a USB connector for you to upload the events, the information from your SAM 950 to the computer. So all those connectors are in the back. There is a waterproof speaker in the back. The connectors are waterproof. So again, what we're trying to do is make it as susceptible as possible to water, depending on the various settings and environments that you'll be encountering. So charge the SAM950 battery pack while the SAM950 is turned on. The display will be charging. So all that will be in the back of the SAM950. Once you unpack your SAM950 from the Pelican case, the very first thing you're going to want to do is power it on, check that the cables are good, and then we're going to begin operating the device. So once you powered up your SAM950, it's fully charged, it's ready to go. You're going to turn it on. You're going to check the screen. It's going to start loading. So it takes about 40 seconds for the SAM950 to load. You'll get that message there, that prompts loading. It takes about 40 seconds. After that, we're going to begin the auto calibration. So the auto calibration starts. It takes about maybe 20 to 30 seconds. It's using the internal potassium chloride source inside the device. So with this source, which is just like standard, it's like a banana, the amount of potassium has. With the source, the system will calibrate, especially the spectrum using the 1446 peak. So it's calibrating to adjust to a change in temperature, change in altitude. If it hasn't been used that frequently, it'll adjust to the various settings. When we're doing this, we always want to remind our end users to remove any check sources within the vicinity of the device. Again, we're trying to check for background radiation as well. So if there is any check sources there, that might affect how the SAM950 performs isotope identification. So we highly recommend that once you're turning your device, check around to make sure that there's no check sources that can affect the device. So this is once the auto calibration is done, ready to go, you're going to be prompted to the main screen. So this is the screen that you're going to primarily focus in on. This is the screen that you're going to see for the majority of the time that you're using the device. You're going to get in the upper left, you can see the library information. That's your ANSI sodium iodide. So it's using the ANSI isotope library list with a sodium iodide detector. If you were using a serum bromide detector, it would say ANSI underscore CEBR. If you were using lanthanum bromide, it would be ANSI underscore LABR. So this is going to let you know what isotope library list you're using. We do have industrial, medical, special nuclear material, but for right now, it's ANSI sodium iodide. You're going to get your dose rate in the center, microsieverts per hour, or rem. So it's interchangeable. Whether you need sieverts or rem, that's something that you could change in the settings. You're going to get your counts per second right there below that, and then if you do have a neutron detector, you'll see the counts per second on the lower left of the screen. The menu bar, so as you can see, there's three options for the menu bar. Right now, what we're looking at, this is the real-time menu. The second one is manual identification, which we'll touch on in a bit. That once you click on that, you'll be prompted to the manual identification screen where you'll be able to perform isotope identification and then kind of increase or decrease the acquisition time. And then sequential mode is used if you're looking to collect events over a period of time within a certain time frame. So if you're looking to do testing every 30 seconds for up to 5 minutes, you would use sequential mode. In the upper right, you'll see the same battery status. So that's where you'll know how long the battery uh, is lasting, or the status of the battery through that upper right battery icon. Right now it says it's 99%. It's green. You'll be able to operate it for about 8 to 10 hours or so, depending on the continuing usage. And last but not least is the rangefinder. So this is good for properly performing isotope identification. So if you're surveying an area, you get a hit, this will let you know to move forward. You still need to get a higher reading to perform the isotope identification. There is maybe a spike in the amount of radiation, but possibly by moving forward, you'll get to the source and you'll be able to perform a proper isotope identification. If you're if you do come across something that's too high, it's going to tell you to move back. Okay, so now that we went over the real-time screen, let's go over the operator controls. So these are the controls that will allow you to operate the device with that control handle. You don't need to use the touch screen. With these controls, you could operate the screen. You have a right and left cursor. You have a down cursor. You do have the up cursor. If you hold it down, that highlight, you'll be able to turn on the flashlight that is included with the device. So you hold it down for 2 seconds, you'll turn on the flashlight. If you click on it again for 2 seconds, you'll turn it off. There's an enter button to execute or select. If you hold the source ID, you'll be able to, if you hold down the enter button for 2 seconds, you'll be able to do isotope identification. There's also the menu screen. You hold that down for 2 seconds, it'll prompt you to the menu screen. It's also used uh, as a way to go back to a previous menu. So again, whether you want to use the touch screen, if it's if you're able to, if you don't have gloves, if you don't have uh, anything that would prevent you from using the touch screen, feel free to use the touch screen. But again, if you want to use the handle, the buttons, left, right, you could do that as well. So that's one of the updates, the upsides that we have with our newer device. Okay, so now you know how to use the device. Now you know what the real-time screen is. It's powered on. You have a battery fully charged. You know about the neutron. You know about the dose rate. You know about the CPS. You know how to use the device. Now the next step is that we recommend you do a background check. So one of the upsides of performing a background check is that you're going to be able to adjust to the change in settings. So if you haven't used the same 950 in a while, by performing a background check, the system will be able to adjust to a change in the background radiation, be able to adjust to the background, adjust to altitude, to the temperature, and things like that. So you go about this by selecting setup menu. So what you're going to do is you're going to press and hold down the menu return button. That's going to prompt a screen that's going to show the event log, setup, and exit. We're going to want you to click the setup button. Once you click that, you're going to be prompted to the settings screen, to the setup screen. Go, go down, click background. Once you touch background, wait for background to complete. It's going to take about 30 to 60 seconds, and then you'll be able to perform background of the environment. Again, once you're doing this, make sure that there's no radiation sources in the area, because it is going to affect how the system works. It's going to affect how the system is functioning. So any cesium-137 button sources that you have, move them out of the way, and that will allow you to get proper background. Measure background reference. So that's the screen. As you can see, once you click background, you're going to see uh, the background. It's going to take 60 seconds. Once it's done properly, if there isn't any check sources, if there's not something wrong going on, the screen will display success. That means that you perform the background, the system is functional, good to go. So you see the screen there, you see the graph, the number one information, that's the amount of data acquisition, how long you're performing this background check, how much counts per second you're getting, and the total count rate. The x-axis refers to the energy unit display, the y-axis refers to the counts, and the spectrum is the real-time spectrum display of the system. So you're getting a good understanding of what's there. So that's a background check. We recommend you perform this background or this test every time you first turn on the device. It doesn't take that long, but again, it's all dependent on what the setting is. If this is just a test, or if you're just doing a quick checkup of the equipment, it doesn't hurt. If this is a national event, if something's going on, um, you might not have time. But again, if there is available time, we recommend you do this. We can't stress this enough. When you're performing a background check, make sure to remove any check sources from the area. Uh, these check sources, we keep getting this time and again, where we're performing training, the unit's working properly, it's got a new detector, but then we forget to remove the check sources from the area. This is going to cause false identification, false counts. It's going to force this system to drift. So again, remove all check sources from the area, especially if you have a very large detector. The standard sodium iodide detector is about 1.5 by 1.5. But if you do have a very large detector, that thing can pick up any check sources, whether it be cesium iodide or sodium iodide, and cause false readings. So again, we want to stress this. All check sources, all blend sources need to be removed when you're performing a background check. Sensitivity. So this is going over our background. Going over our algorithm. We can't really go into huge depths about this. We can't really talk about our algorithm or what it works, but this is kind of the secret sauce. It's how it functions. Um, we did change from our older QCC algorithm to our new wavelet algorithm, which allows for much more sensitivity. It is constantly adjusting, so this will allow our system to be more sensitive than it has been in the past. So we're extremely excited about this. It does give us a boost of almost 10 below background. So this is very beneficial for all applications. Having a system that's more sensitive will allow us to find, detect, and identify check sources or radiation sources or abnormal sources much faster. So now that the SAM is ready to operate, on the gauge screen, you're going to see, again, all the information that we went over. Uh, right now, it's going to be in variable mode. So what variable mode is it actually collects the statistics and the alarm goes off of any abnormal fluctuations that might come from that might affect the dose rate. So it's not based off of, oh, if we hit 2 to 3 rem, that's when we'll alarm. It's more so if there's a spike or an increase in the statistics, that's when the alarm will go off. So there's a gauge screen that's good for collecting information like dose rate counts per second, neutron counts, and then there's another screen, one of my favorite screens, finder mode. So with finder mode, you'll be able to easily find sources using this graph. So by using the counts per second that are displayed in the graph, you'll be able to find any abnormal levels of radiation with this peak. So if you're surveying an area, you're surveying, it's the line just doesn't move, the surveying, and then you hit a spike. Chances are there's something there that you could go back to. So it's about now it's about 60 seconds. So that graph is about a 60-second image of how much information you're collecting. And then you'll be able to survey. You see something, it's going to spike, then you can always go back to it. So it's going to display a momentary increase in activity more effectively. It's going to be able to let you find sources much more easily without just having to rely on CPS or the dose rate. Okay, so now we know how to use the SAM950. Now we know how to operate it. Now let's use the feature that it's intended uh, to be the intended usage of the device, and that's isotope identification. So with the SAM950, the main reason you acquire this unit is to perform isotope identification. You found radiation. Now you want to know what type of radiation it is. You want to know whether it's medical, whether it's industrial, whether it's just background radiation, or maybe it isn't. Maybe it is a special nuclear material. You want to know that this device will be able to identify the isotope and then allow whoever's using it to proceed as uh, as trained. So if it is just medical, chances are it's iodine 131. You don't have to do much with it. If it's potassium, sodium, things like that, not much of an issue. But if you do come across something like cesium 137 or uranium, plutonium, that's where this system will let you know, hey, we need to call a federal agency, we need to call a State Department, we have to get everyone on board. So once the count rate is greater than background, you're going to get an alarm. That gauge is going to turn. It's going to go up, up, up. It's going to turn red. You're going to hear audible sound. It's going to be a siren that goes up and down. So again, just going back to some of the helpful operating messages. Move forward. That's going to let you find uh, that typically indicates that the count rate is less than optimal for isotope identification. So it wants you to move closer. Um, Move back, that means that the count rate is higher than optimal for best ID, so it's too much. It's too high. The detector might be oversaturated, so move back. Once you get that in range, that means this is the perfect optimum condition for isotope identification. So once you get that in range, that means you can click it. Let's perform isotope identification. And the last one is danger. So once it hits danger, that means the radiation is too high. You have to get out of there. You have to move to a much more safe distance. So those are the four helpful messages that are going to allow you to operate the system properly, to use it to its best capabilities. So once you get an alarm, once you know that there's radiation there, there are three ways to execute manual ID, or what we like to call it isotope identification. So you press and hold the enter key for about 2 seconds. That will prompt you to manual identification, or you could touch the manual ID on the screen. It's a soft key. You click on that, it'll allow for isotope identification. The third method is to use the handle. So by using the left right buttons, you can scroll and position the rep bar on the manual ID, and then again you press enter, and that will prompt you to manual identification. So again, this is why you acquire the instrument. This is why you're using the instrument. It's not a pancake probe. It's not a survey meter. This is a very sophisticated portable isotope identifier. So this is going to let you know what is going on. This is intended usage. This is why it is a bit more expensive than a simple Geiger counter. This is why uh, the intent usage of the devices. So once you click manual isotope identification, you're going to be prompted to the isotope identification screen, the manual ID screen. So now you're going to see the spectrum right there. You can see that the individual click manual ID. They're collecting information for 60 seconds. You're getting your CPS, your total count. Once this is done properly, you're going to get the isotope there. So right there, you see cesium 137. You see the 662 peak. You see the confidence level. You can actually adjust the acquisition time. So right now the standard is 60 seconds. If you need it to go up to 120 seconds, things like that, no problem. You just by touching the buttons up or down, you can increase or decrease the measurement time in real time. So the left screen, you see the spectrum. You're going to see a little white line, a little white dot on the lower left of the screen. By clicking that, you could go from identification screen that's going to show you the spectrum to the right to classification screen that's going to display the isotopes that you're using, that you're seeing. So if it's just cesium 137, you see cesium 137 and the dose. And it's also going to color code it. Again, if it's special nuclear material, it's going to be purple. If it's industrial, it's going to be blue. If it's medical, it's going to be a light blue. If it's norm, it's red. And if for whatever the reason we can't find it or can't determine it, it's going to be unknown. It's going to be red. So both screens are good for kind of determining what the isotope is, and if you want to exactly figure out the dose rate per isotope, you can do that by going to the color coded graph bar screen. One of the upsides of having a touch screen is the ability to use it. So with the touch screen, you can actually zoom in, zoom out by, so you could touch it with two fingers and extend or extract. What this does is it's going to allow you to zoom in, zoom out per region. The second one is to tap twice. This is going to, what this does, it actually takes you back to original spectrum scale. So if you zoomed in too much or you zoomed out by just tapping it twice, it's going to take you back to the original screen. You could also hold and move the left or right of the spectrum to go to the lower energy line or to the higher energy line. And last but not least, you could touch and hold x-axis. This is going to prompt a blue cursor. This will allow you to, with this blue cursor, you could hover over a peak, see what exactly that peak is, see what that energy line is. So again, if you don't have gloves, and if the setting and the environment is right, feel free to use the touchscreen feature in order to manipulate the spectrum. So you found radiation, you decided to do manual isotope identification. You did it for 60 seconds. Now you created an event. So now once the event is created, it's going to prompt you to the event report. So as you can see there, the event report is going to give you a lot of information. Number one, it's going to give you the status bar. Again, the status bar is an indicator of the time, the date, the battery life. It's also going to give you number two, status bar will show the name of the device, what library list you're using, and the alarm mode, whether it's a fixed mode or a variable mode. Number three is the event information, the event number, the duration, how long you did it for, the date, the time, and the location. And number four, detected isotopes. So what isotopes, what nucleides were actually found. So whether it's cesium iodide, whether it's cesium 137, uh, things like that. And favorite. So you can actually make this a favorite isotope or a favorite event and keep track of it. Number six, comment. You could include additional comments. Hello world. I'm currently in San Francisco. There's a huge explosion. I performed isotope identification and found that there's uranium and plutonium. I'm not sure if this is right. Feel free to let me know. All that information will be included in that comment section. Number seven is reachback. How do you want to send the information back? So normally this will be saved to your SAM 950, but if you want to send it to reachback, whether it be an email address or number eight, route responder, you can do that by clicking those two buttons. All you have to do is click on the buttons, and then it's going to prompt you to use the screen, and it's going to send it. So real fast, reachback. And then media icons. So you could attach photos, videos, or record sound. Do just an audible recording of you explaining the situation or going over what you're seeing. So, and then the media list. Those are the attached photos, the videos, and all that information that you included will be. You can see that in that the right of your screen. And last but not least, number 11. If you don't want to keep this event, you want to remove it. All you would need to do is click on that remove event. You're good to go. Very simple. So you save the event, it's on your device. Now you want to find it. So the way of finding this is to go back to your real-time screen. The manual ID event is automatically generated and saved to the 950. The event log will now provide you a summary of all the events that you've saved. So you want to find it. You do this by pressing and holding the menu and return button on the handle, or you could also do it on the menu return icon on the screen. So you press the enter button to select the event log. It's going to prompt you to the event log screen. Up or down will allow you to select each specific isotope. Once you click the once you click that event, you'll be able to see all the information that you need: the dose rate, how long the alarm was for, and what isotopes were detected, the date, the time, longitude, latitude, and all the comments. So this is the event. This is a specific event that we just clicked on. The event ID, that's going to show you, again, like I said, the isotopes that were detected, the acquisition time, the average counts per second, and the total count. So you could use the touchscreen techniques to allow for the spectrum manipulation, and all the information will be displayed on the right-hand side of the screen. Again, to reiterate, if you want to include comments, all you would need to do is press comment and type in any additional information that's going to be helpful to you or helpful to whoever's processing or looking at the events. All you would do is go down to the comment section, click on that, and once you're done, touch done to save. We already talked about this initially, but again, if you do want to include any photos, videos, you would do so by hovering over photo video. You press enter, and then you can choose whether to include a video or a photo. Okay, so now that you have your event, now you want to send it back. So there's two methods. There's one of them is email. So if you do have an email address that you want to send to, you go to your settings, you go to email account, and then you set up the account, the reachback that you want to receive the information. So let's see here. You click address, you put that reachback account below the sender information. You would include all that information in there, the address, the password, the server, and the port. So that's your email information that you would need to include in there. So you would fill in the email accounts of the PDA and of the reachback location. Very simple, intuitive, but as always, if you have any questions, let us know. But you're going to need this if you do want to transmit events to a specific email account. So reachback. So once you have your email set up, now you want to send it back to that pre-assigned address. So you go to the event log, you touch and hold an event for 2 seconds. So any event, you touch it, hold it for 2 seconds. It's going to prompt a screen that says select a transfer method. So you would send it via email. So you click on email. It's going to say, do you want to transmit the event to a reachback center? You say yes, transmit. You click on that. And if it is successful, transmit success, it's going to say success. So again, we're trying to make it as easy as possible to transmit information. You hold the event for 2 seconds. You select the transfer method of email. It says, do you want to transmit the event to a reachback center? You hit transmit success. Okay. Easy, straightforward. Again, a lot of this feedback, or a lot of these features are due to the feedback that we get from our end users. So keep them coming. Any questions at all? As always, let us know. We're more than happy to help you, work with you to get this set up within your group. As always, we're very flexible. We appreciate all the support that we get from our customers. We appreciate all the feedback. So any questions, feel free to include them in this training course. But any questions, anything else, feel free to let us know. Again, on behalf of everyone here at Berkeley Nucleonics, we appreciate you as a customer, you as an end user, and anything we could do to support you and your group, feel free to let us know. Thank you so much. See you next time.